Good morning students, welcome to Kiran's tutorial. In part 1 we discussed about introduction part in solid state, and part 2 we are going to discuss remaining classification of solids, different kinds of solids. Three kinds of solids. The first one covalent solids, the second one ionic solids, and third one metallic solids. So remaining three kinds of solids. So what about their constituent particles and force of attraction? What about its melting point and boiling points and electrical conductivity and examples? So if you go to the first one, covalent solids. So what is covalent solids means? The solids in which constituent particles are non-metal atoms. So here non-metal atoms. So the solids in which constituent particles are non-metals, non-metal atoms, those solids are called as covalent solids. Clear? That is the definition of covalent solids. So constituent particles, non-metal atoms are present. Then, if you go to the force of attraction, in the name itself it is there. Covalent solid, covalent bond. What is covalent bond? The bond is formed between two atoms by sharing of electron. We know the ionic bond, covalent bond, coordinate covalent bond. So how the covalent bond is shared, how the covalent bond is formed, means by sharing of electron. So by sharing of electron, so that's why strong forces is present. Clear? If you want to remove or break the bonds, we need more energy because there is a strong force of attraction is present. So here, what is the force of attraction in covalent solids? Covalent bond. Covalent bond is present in covalent solids. Okay. Then, if you go to the melting point and boiling point. So melting point and boiling points, due to the presence of strong force of bonds, covalent bond, by sharing of electron the bond is formed. So due to that, very high melting point and boiling point is present. So these are very high melting point and boiling point. So very high melting point and boiling point. Then, what about its electrical conductivity? Covalent solids can allow the passage of heat and electricity? No. Why? What is the reason? Because to allow the electricity to pass the heat means free ions are required. You know that when free electrons are present, free ions are present, there will be passage of electricity or heat. But here, by sharing of electron, there is no ions, no polarity. So that's why these are insulators. These are covalent solids or insulators. Means it cannot allow the passage of electricity. That's why you can say very low electricity can conduct. But finally you can say these are insulators. Clear? Insulators. But some exceptional cases are there. Graphite. It is made up of non-metal atom, carbon, but due to the presence of pi electron, pi bond, it can allow the electricity. It can allow the passage of heat and electricity. Clear? So that is one exceptional case. Graphite. It can allow the electricity. It can allow the passage of heat and electricity. Depends on the structure. There is a pi bond is present, free electrons are present, movement of electron is present. So that is why diamond is a good conductor of heat and electricity. And the most important point, examples which are called as, which are belongs to covalent solids and silica, diamond, graphite and silica. These are example for covalent solids. Covalent solids. Clear? So that's about covalent solids. Then we go for the second one. Ionic solids. Ionic solids. So ionic solids, in the name it is there, ions. What is ions? Ions are which carries charges. If positive charges are there, those are called as cations. If negative charges, those are called as anions. So in ionic solids, constituent particles, ions, means ionic solids are made up of ions, nothing but you can say cations and anions. Cations and anions. So in ionic solids are made up of cations and anions. They are made up of cations and anions. So these are the constituent particles present in ionic solids. Then what about force of attraction between between molecules? If there is two charges are there, positive charge, negative charge, there is electrostatic force of attraction is present. So what is the force of attraction? Electrostatic force of attraction. Electrostatic force of attraction is present between cation and anion, between positive and negatively charged particles. So constituent particles are ions in ionic solids. Force of attraction is electrostatic force of attraction. Then what about melting point and boiling point? Melting point and boiling points. Low melting point and boiling points, or high melting point and boiling points. So due to the use of electrostatic force of attraction, high melting point and boiling points are present. So if you want to remove to break the bond, we need some amount of energy to break the electrostatic force of attraction. So high. Then what about electrical conductivity? Ionic solids can conduct heat and electricity or not. In solid state, there is no free ions. If NaCl, see NaCl, it is positive and it is negative. One NaCl, one chlorine is present, one positively charged, another one is negatively charged. So there is no free ions, but when it is dissolved in water, the free ions are present. Due to that, in aqueous state, in solution, it is good conductor of heat and electricity. So in solution or in molten state or in fused state, ionic solids are good conductors. Conductors in fused or in solution. So that is ionic solids. Then if you go to examples for this ionic solids. See, NaCl, KNO3. So these are some examples for ionic solids. Or like ZNS. These are examples for ionic solids. Clear? Then if you go to the last one, that is metallic solids. So in metallic solids, constituent particles. What are the constituent particles in metallic solids? Metals. Metals are the constituent particles in metallic solids. And what about force of attraction? Metallic bond. Metallic bond is present in metallic solids. And what about melting point and boiling point? We know that iron, it is a metal. Low melting point or a high melting point. So high melting point and boiling point is present. So high melting point and boiling point. And these are the conductors of heat and electricity or not. If there is a current, it is passed through the wire, that is called copper. It is a metal or not. So conductors of electricity, heat and electricity. And the last one, what are the example? You know the iron, silver, copper. So these are the example for metallic solids. Metal, they form metallic bonds. So metallic solids. Clear? So that's about see, you can write here silver, it is example for metallic solids. Clear? So that's about classification of solids. Classification of solids. So crystalline solids are classified into 4 types. The first one, molecular solids. The second one, covalent solids. And third one, ionic solids. And fourth one, metallic solids. In part 1, we discussed about molecular solids. Molecular solids are again classified into 3 types. That is non-polar molecular solids, polar molecular solids, hydrogen bonded molecular solids. So if you see the part 1, there molecular solids and types are there. And in this part 2, the remaining topic, that is types of crystalline solid. Clear?